We're going to continue to number 3 and graph this rational function. In the previous video, I graphed number 1 and 2 from this worksheet. So here we have our strategy again, and we're going to work our way through this. So for number 3, we want to factor. So we see here that 2 does not factor. In the denominator, we can factor out an x, and when we factor an x, we get an x plus 3. There's no canceling that can be done, so we factor the numerator and denominator as necessary. Now we're going to go through our list of things we've done before. We have wholes. That's from number 2. And wholes only occur when things cancel, so nothing canceled here, so this is a none. Then step 3 is x-intercepts or zeros. And you can read it there, but zeros occur at values of x that make the numerator equal 0. Well, the numerator is 2. It is 2. It has nothing to do with x. So once again, just like the one, number 2, if you've watched that one, there ends up being no x-intercepts. I shouldn't say that because that could be confusing. One of the factors cancels, so in number 2. Next, we go to vertical asymptotes. Vertical asymptotes are values of x that make the denominator equal 0. Well, whenever you just have an x alone, x equals 0 would make that 0. So x equals 0, and then from this one we also know it could equal negative 3. Those are both multiplicity 1, which means on each side of the asymptote, if one side goes down, the other side will go up when we think left or right. So those took care of vertical asymptotes. Now let's go to horizontal or slant asymptote. As mentioned before, these first 3 fit part A here. The degree of the numerator is less than the degree of the denominator. The degree of the numerator is 0. Because there's no variable written, which means it's an understood x to the 0. Maybe I'll put it in a different color so we remember it wasn't actually there, written there to start with. So degree 0, and then in the denominator, we can look here, or we can look here. If you multiplied this out, this would be degree 2. And so it does fit part A here, and so we know that that y equals 0, which is the x-axis, is a horizontal asymptote. We go to other points, and normally when we do other points, we find the y-intercept. However, we see up here, and maybe we could start graphing these things, that the y-axis is a vertical asymptote, so there will not be a y-intercept. So let's go ahead and graph what we have. There's no holes, there's no x-intercept, so not much to graph yet. There's a vertical asymptote at at x equals 0. So I'll put a dashed line over that, and then also at negative 3. And we have a horizontal asymptote on the x-axis, so we can put those in there. And we don't have a y-intercept. We actually don't have any points right now, so we need to, there's a couple things we can do here. We can plug in a point. So maybe we plug in 2. So what happens if x equals 2? So I'm going to plug in 2 into my function. I can use either form of it. I can use the first one or the factored one. It doesn't matter. You'll get the same thing. I'm going to just go ahead and think about this first one here. So when we plug in 2, we will have 2 over 2 squared, which is 4, plus 2 times 3, which is 6. That's 2 over 10, which is 1/5. So at 2, we have 1/5. So I'm going to try to write that on there pretty close to the x-axis. I'll even zoom in a little bit. So here's a point 2, 1/5. And now we can start graphing. Thinking about this, we have a vertical asymptote here at 0, so our graph either has to go like this, or our graph has to go down like this. However, the red does not work because it crosses the x-axis, and we know there are no x-intercepts. So it is not the red, which means it's forced to be the black. And so we have that black part there, and then it goes through 2 1/5 and then gets closer and closer to the x-axis. Here at this vertical asymptote, it's going up closer and closer to the the y-axis. The vertical asymptote, the multiplicity was 1, which means since it went up on the right side of the vertical asymptote, it needs to go down on the left side of the vertical asymptote. All right, now we're in this other branch, this middle branch. Well, it looks like this graph is going to have to go, and it's going to have to turn around somewhere and go back down because it doesn't have any x-intercepts there. What we can do, if we want to be a little more precise, I actually don't mind if you just graph something like this. That's okay with me, but let's be a little more precise and let's plug in -1. At least give us an idea. So we'll plug -1 into our graph here. So we get 2. -1 squared is 1. Plus 3 times -1, which is -3. So we get 2 over -2, which is -1. So we're going to have the point -1, -1. So our graph is going to come up pretty close to the x-axis. It's going to have to turn around somewhere here. Again, we don't need to be exact. It has to turn around because we know it does not go through the x-axis, and then it has to approach that vertical asymptote again. Well, we reached another vertical asymptote. That's at -3, which also was multiplicity 1. Again, that's the multiplicity is whatever implied or written factor is there. Sorry, exponent. 1 is odd. And so we'll just slide over one more time when it's odd. Odd multiplicity will be on opposite sides of the x-axis. So here at -3, I'll highlight this part. This is going down. It's on the bottom side of the x-axis. So on the left side of the asymptote, it has to be going up. So we'll put an arrow there. And really, it's going to come down, and it has to then approach the horizontal asymptote. If you wanted to be more precise, maybe you could plug in the point -4 and see what that equals. But I'm not going to do that right now. So right there is the graph of our f of x function.